Air is being pumped into a spherical balloon. At time t, the volume of the balloon is v of t, and its radius is a function of t. What is the derivative dv over dr and dv over dt represent? The volume of the sphere is 4 over 3 pi r cubed. If we differentiate v with respect to r, it is straightforward. 4/3 pi is a constant multiple. The derivative of r cubed with respect to r is 3r squared. And so this is 4 pi r squared. What does it represent? It represents the rate at which the volume is changing with respect to the radius, meaning if the radius increased by 1 unit, the volume would change by 4 pi r squared. Now, if we express v in terms of t, then we would have v equals 4/3 pi r of t cubed, where r of t is now in terms of t because the radius is a function of time. If we differentiate v with respect to t, we would have 4/3 pi, which is a constant multiple, times 3 r of t squared. But the inner function is r of t. We would need to multiply the derivative of r of t, which is dr dt. This is implicit differentiation. The 3 and the 3 canceled out, so we would end up with 4 pi r of t squared dr dt. What does it mean, dv dt? This is the rate at which the volume is changing if time increases by 1 unit. If the time is increased by 1 unit, the volume would change this much. The difference between dv dr and dv dt is that with dv dr, we would need to know what r is and plug the radius into r squared. With dv dt, we would need to know what the time is to plug t into the radius function and then square it. In addition, we also need the quantity dr dt, which is the rate at which the radius is changing with respect to time.